definition. If an angle theta is in standard position and point pxy is any point on the terminal side of theta, then by the Pythagorean theorem, r is equal to the square root of x squared plus y squared, where r is always positive. Well, allow me to demonstrate a picture. So I'm just going to draw my angle in standard position. There we are. And I'm just going to make my triangle in quadrant number 1, although it holds true for all. And if I go through point xy, there we are. And what we see is that my angle, maybe I drew that a little bit too quickly. And what I see is that this has point xy. If I make a right angle triangle right here, what we may be able to see is that I could create a right triangle there. The length of the bottom would be x, the height of the triangle would be y, and the radius vector r, by the way, r is radius vector, is the hypotenuse of the triangle. So really, if I have any triangle with coordinates x, y, my radius vector will be the square root of x squared plus y squared. So let's recall the three basic trigonometric ratios here. We have sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. If point P, x, y is any point on the terminal arm of an angle in standard position, then it can be shown that cosine theta is equal to the x-coordinate divided by my radius vector. Sine is the y-coordinate divided by my radius vector. Tangent theta is my y-coordinate divided by my x-coordinate. So this picture here, I might use. So I'm going to start with sine theta. Now, sine theta is equal to, most times we like to think of sine theta is equal to the opposite over the hypotenuse. And if I'm calling this theta, theta would be in this corner, this side would be my opposite, this side would be my adjacent, just like labeling a right angle triangle. And what I notice is that I could rewrite sine theta as my opposite, which is really my y-coordinate, divided by my hypotenuse, which is the length of my radius vector r. So I've written it as the absolute value of r, just to remind us that it's always positive. Now switching colors. Cosine theta is equal to the adjacent over my hypotenuse, by definition. Looking with respect to theta, my adjacent is x. So cosine theta is going to be equal to x divided by my hypotenuse. And in the triangle that I wrote, it is going to be divided by my radius vector r. Now, tangent theta is going to be my opposite divided by my adjacent, TOA. So tan theta is equal to going to be my opposite. If we notice, my opposite is described by the y-coordinate on my triangle. The adjacent is described by my x-coordinate. And what we see here is that cosine, sine, and tangent are described as follows. Sine theta is equal to y over the radius vector r. Cosine is equal to the x-coordinate divided by my radius vector r. Tangent theta is equal to my y-coordinate divided by x.